Today's episode is sponsored by Siemens. Visit them at usa.siemens.com/CNC4U. That's CNC, the number 4, YOU.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello, and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. And make sure to like and subscribe to get new episodes delivered to your feed each week. I'm Amy Bryson, contributing lead editor of Smart Manufacturing magazine. Today, we'll be talking about how technology can help bridge the skills gap in advanced manufacturing. And my guest is Chris Pollack, manager of the Siemens Virtual Technical Applications Center. Now, that's an online educational initiative that helps companies and their employees keep their skills up to date to meet the rapid changes in technology. So Chris is an excellent guest for the topic of using technology to help bridge that skills and talent gap that looms over manufacturing right now. Thank you for joining us, Chris, and welcome to the show.
Thank you, Amy. I appreciate the opportunity, and I look forward to talking to you today.
Absolutely. So before we jump into our discussion, can you give our listeners just a bit of background about you and your role at Siemens? And I also just want to let our listeners know, you may also know Chris by his moniker, Mr. CNC.
Yeah, yes. Mr. CNC, our YouTube channel. I've been working for Siemens now for going on almost 14 years. I came to Siemens as a product specialist, so I really started in the industry and the trade as a machinist, and then moved into mechanical engineering and whatnot over my course of my career. But I've always heavily focused on kind of the control and CNC integration side of the piece. So once I came over to Siemens, it really afforded me a great opportunity to kind of collaborate and drive, their products into the space by educating kind of the masses, educating the customer base on, how can you optimize processes? How can you refine different things? So, we stood up a full training program, as you mentioned before. We have the majority of it's online because it allows us to really kind of break down the geographical barriers that we face in a country this large. Interestingly enough, I was surprised to see how many global attendees we have that will attend our classes. So we offer not only self-paced modules so people can attend and kind of watch whenever they want, but we do a lot of instructor-led classes. And, I'm a big advocate of instructor-led because I think when you just do self-paced by itself, it's great if every piece of the puzzle falls into place and you just clean and smoothly transition through the material. But what happens when you hit a roadblock, right? There's a question you can't get answered. So having that product specialist there kind of guiding you through your learning journey really is helpful. And it always amazes me. I mean, I was just doing a class just the other week, and I literally had one of my students was in Portugal. So it was the middle of the night for him, but there was such a need to learn this content that he was there in the middle of the night and doing his homework assignments, and it was great. So, yeah.
That's really cool. Yeah. And I love that you offer different ways to learn because people learn differently. So that the self-guided stuff is great for maybe brushing up on things, but to have that immersive, experiential kind of one-to-one, one-to-many makes a big difference, I would imagine.
Yeah, for sure. Absolutely.
Wonderful. Okay, so let's get to brass tacks.
All right.
So the skills gap is upon us, right? And it's only getting greater. So on a macro level, what trends are you seeing in the industry that can help bridge this gap? And then specifically, I'd love if you can kind of drill down a little bit and talk about, given your space in the world and your experience, how technology can truly help when it comes to companies specializing in small batch, high turnover production. So let's start on a macro level first. What trends are you seeing right now in the industry?
So I think our users, right, our customers, let's get right down to the actual manufacturers utilizing this technology. They face two key challenges, right? And challenge one is there's just no workers available. So that's a huge problem. Or challenge two, they have a workforce, but there's a huge skills gap in that workforce. So they're really not prepared to be able to handle the level of technology, and they just don't have the knowledge for there. And I think what we see kind of two different avenues depending on the challenge. For sure, in areas where you can't just get the people, right? It no matter how many ads you post out there, nobody seems to come.
Yeah, zero is zero.
Yeah, zero is zero. So there, that is certainly an area where we're finding the adoption of automation. We all, hear robots. There's plenty of other like gantry solutions, but some form of a way of, filling the gap of not having that head count. I don't want to say displacing, because you're not displacing. Again, we're still zero. But automation tends to fit that gap pretty well. It is more complicated, but generally speaking, in those kind of cases, you'll have a couple key people within that organization that are very advanced, so they can kind of help drive you into that technology space, or at least you're training one or two key guys to get them up to speed to help you get to your volume production numbers you want to get to. Now, when it comes to you have some personnel, you can bring in the people, but there's a significant skills gap. What we're seeing more and more commonly is, how do we take the machine tool, right, and get it to a level where it can help kind of offset the skills gap there. So it amazed me, like, we've had probes on machine tools for years. 30 years, but they were always used very basic setup operations. I have my machinist is at the machine getting set up, and he has to datum the part and find a zero location. So he'd use the probe. But nobody was really using them for what we call in-process probing, where you can have an operator put a piece of raw stock, a piece of material into the machine. But now the problem comes in with his limited skills. Did he get it positioned in the right spot? Is it aligned? Is it going to be in a position where we're not going to scrap apart? So you can now leverage the CNC and give the control program just a little bit more capability to say, all right, now I'm going to come down. I'm going to check, did it come into the right location? If it didn't come into the right location, is it close enough that I can align the machine to it and I can continue on? And, it sounds like a simple thing, but it amazes me every time we do any kind of content on this topic, especially in-process probing. It is probably the number one most attended topic of all of our topics. And I think that speaks to, that need, that requirement that people have to not only be able to offset that gap from that side, but even maybe make adjustments to the system. And, and that's certainly something we could talk about further.
Yeah. So talk to me a little bit about some of those light bulb moments that you have with people when you're talking about training and bringing technology, into the shop floor or, the broader company, right? Are people afraid of that, just generally speaking? Is it a fear of change? Is it a fear of, with the workers that do have, we're not talking about the people who aren't there, but the workers who are there, are they afraid they're going to get displaced? Talk to me about what some of those experiences have been like.
So I would say that I don't run into a predominant fear of being worried about displaced. I think everybody knows that there is a substantial skills gap and workforce deficiency. So those that are in the trades, I think they all feel pretty secure that, hey, even if I don't want to stay with the ABC company I'm working for today, I can walk down the road and have a job within hours, if not minutes. So I don't think that's as much of a challenge. But I will say that when introducing new technology to a company, there is always a fear of change. And I used to work for a gentleman that used to say that you have to mitigate the risk, right? So every company and every acquisition you make, every change you make to your processes and your business, there is risk involved. So how much can we mitigate that risk to allow them to make that shift in technology? And, that's something that we've done a lot in paying attention to how the control's built, how the system's laid out. How do we make our technology feel approachable by the user? And and not something completely unique, right? Like we're not trying to teach somebody who's, grown up with the iPads, right? And the iPhones and smart technology. We're not trying to teach them, an original arcade game system, right? So they've got to learn all these arcade commands and that's totally foreign to them. So how do we create a system that feels like technology they already understand? And I'll give you a very simple example of that. We had implemented touchscreen technology quite a few years ago for that reason. And then we went to the next step and said, well, if the workforce of today understands multi-touch technology, right? You grab your iPhone, you pinch, you zoom, you kind of use your two fingers to rotate. Wouldn't it only make sense to have the machine tool behave the exact same way? So we've implemented that technology to be able to kind of ease people into what it can be a very, very advanced system.
Yeah. It sounds like, you use a lot of insight to make those changes so that it feels intuitive, and it feels familiar, but it also can move the needle for, say, your typical machine tool operator.
Absolutely.
Right. So let's talk about some of the latest advancements in CAD, CAM, and CNC. I'd love to hear your thoughts from a few different perspectives. So first, can you talk about the machine builder's perspective of, say, like design, simulation, and the digital twin? And then maybe switch gears, focus on the end user's perspective, especially as it relates to part programming, simulation, and even training. So let's start from the machine builder's perspective.
So one of the things that, we recognized quite some time ago is the challenges for a machine tool OEM bringing a new product to market, right? That process from conceptual design to casting your first pieces to finally building a prototype and then getting something that's sellable is a long process. And they needed to kind of truncate that time to market segment to make them more nimble and more effective to get new technology out. So what we've done is we've developed a system where we're really leveraging a full digital twin that not only shows the machine motion virtually in a graphical space, but then can also connect the CNC controller capabilities so we can really get a true one-to-one of what the machine's going to do, how it's going to perform, how it's going to behave before you've even cast the first part. And what it allows you to do by leveraging this digital twin concept is you can now take processes that were traditionally very linear, right? I could have never started working on commissioning the control system until I had all my pieces cast, machined, bolted together, and then we could bolt on the control. But now that we can start to do this stuff in a virtual environment, we can actually have multiple processes going on, right? So you can have the production of the components happening at the same time as the initial commissioning of the control system, because we don't have to wait for those previous steps. So it dramatically shortens the time to market of a machine tool. From there, at the end, you actually end up with an interesting asset because you've now created an environment, right, that can fully simulate the entire process. So imagine this, right? Boeing, let's say, we'll use Boeing as an example. They go to a machine tool manufacturer and say, hey, we got this widget, we got this part, we need you to design a custom machine for. And they say, okay, well, let's take that. We're going to suck that in. We're going to, from a CAD, mechanical engineering perspective, design up a machine that's going to hopefully fit your needs. But now we can plug this into a full digital twin with the CNC control, completely commissioned, and we can start to run cut tests, time studies, evaluate whether the product is even potentially machinable and manufacturable through this new design, this concept, get sign off by the customer. And this is all happening even before you've really built the first machine. Now, at the end of the process, though, you now have this digital environment that is now also usable by the end user. So we've created something that aided to the OEM's design, but now I have a digital twin that can be now offered to the end user, whether it's sold or given. I mean, that's up to the OEM. But it creates an entire kind of holistic environment. And we've seen that heavily adopted by more of your advanced manufacturers. And when I say advanced, from a technology side, right? People that are using 5-axis machines, mixed technology machines, those are the machines that are really critical, that you can be sure that the process you're about to do is not going to jeopardize the integrity of the machine, i.e. crash the machine. But the other interesting area where people have leveraged this digital twin technology, because the environment fully simulates the entire process that a user would do in the real world on the floor, they're also using it for training purposes. So you can now take these unskilled workers that we talked about earlier, you can sit them in front of this quote unquote simulator, right? Almost like a flight simulator, but now it does everything the machine tool does. They jog it around the way they would jog it around. They see the 3D model moving as if the machine was right there. So you can start to get your workers up to speed on this technology, and there's really no risk to you because they can't crash the machine. So it becomes this perfect sandbox for educating that user that we have to bridge that skills gap on.
Yeah, that's really cool and very cost effective, and really thinks about kind of the long-term vision of how to employ new training techniques. So that's really cool.
Now, one of the challenges I will say on the digital twin, because a lot of people, they look at this and say, well, digital twins, they've been around for 15 years, right? There's plenty of simulation packages out there that shows the machine model moving around, running some G code. One of the things that's kind of changed, and it's probably the most critical piece of the puzzle that was not able to be reproduced in the past, was you never really knew the behavior of the real machine, however, right? You had a third-party company that was making an assumption that, well, the CNC is going to move this way. And usually the guess was probably correct. The problem is when the guess was wrong, now bad things happen. So the way we were able to overcome this is we actually took the brain of our CNC, which we call our kernel. We created a virtual variation of it, or a virtual kernel. And that's actually what's driving that model. So the decisions that the real machine would make are the exact same decisions that the digital twin would make. And that's really kind of the game changer here that we never had in the past.
Yeah, that's huge. Let's pivot a little bit and talk about lights out manufacturing. So a couple decades ago, lights out manufacturing was seen as an alternative for repetitive machining operations. And, the role of the machinist was maybe less critical. So how are manufacturers today striving to implement a more holistic, quote unquote, dark factory approach by incorporating robots for both machining and part loading and unloading?
So what's interesting in that technology space, and I think the one key change to the way it was done prior to this, is we're able to do things now with the CNC controller that really wasn't possible even 6-7 years ago. And what I mean by that is the traditional application would be, okay, I want to bring a robot into some form of a machining cell, and this is going to tend 1, 2, 3, however many machines. What you ended up having is you had a brain of the robot that was driving that completely independent, the brain of the CNC. There is some handshaking between the two, but effectively, the CNC doesn't really know exactly what's happening to the robot or vice versa. So the motion of the robot had to be kind of very limited, because you couldn't do anything complicated, because it was really just kind of picking and placing. The other problem that a lot of people find in this scenario is they don't have the ability of then simulating the entire cell with any level of accuracy. So what we've been able to do, and we've been able to bring to market, is a scenario where we can actually run the robot as a second channel of the CNC controller. So now imagine this. I have a machine tool, a milling machine, but the machine's not just running its own processes, it's also running the robot. And when I say running the robot, that means that the operator of the CNC that knows how to run the CNC, right? They know the language and everything. He now not only sees the program of the robot in that CNC machine, that milling machine controller, but it's the same common language he knows. So he doesn't have to learn a unique control. And now we have a much more sophisticated brain driving the robot. So what you'll see is now we can multitask the robot. So I can not only take a robot and take a part in and out of a machine, your simple, what we would call pick and place operation, but I can now actually do complex motion with the robot. So we have a lot of applications where, the robot comes into the workspace, maybe removes the part out of the machine, lets the machine go and run, but now it goes over to a secondary station where maybe there's a little deburring machine running, and now the robot will effectively hand deburr the part and is running this complex motion. And since it's the one brain driving both, we can now do all kinds of complex stuff. Like I can be removing and adding parts to a table that's moving. It's funny. I saw a demo years ago that it's just kind of a silly little demo, but it really kind of opens your mind to what's possible. So we had a robot running, cutting apart, a machine running, cutting apart, and we had the robot following the machine tool with a vacuum cleaner, cleaning up all the chips. Sounds silly, but if you think about the complexity,
but
right?
It's huge. I know.
It allows you to take this technology to a completely new level.
I know, and it's so practical and it's so meaningful. It's crazy, and I love that that's stuck with you all these years too. Right? It's a perfect example. So, when it comes to tool management, how can you automate a process that has been traditionally up to the machine operator? So what does that process look like?
So there's a couple things that come into play when you start to talk about, tool life and, just the accuracy of how a tool is interacting with the part. So some of the things that you kind of come into play is, well, how long has a tool even been running, right? And can we track that? And what happens when that tool effectively goes outside of some measures, right? Some statistics that we give the system to say, okay, this tool can run for 2 hours and then it's bad. So what we've done, and we have, quite a few other control manufacturers have started to adopt this concept, is we allow the control the ability of now tracking the use and the life of that tool. As the tool gets ready to expire, then we can do something that's called leveraging with sister tools. So we can actually create multiple tools in the same system that effectively are told to the system to say, I can be replaced with anything that tool can do. I can do better, right? One of those kind of scenarios. And the system will then, it's smart enough to then say, okay, my tool has used up all its life. I'm now going to tell the operator this tool is no good anymore. You need to replace it. But so I don't stop running and adopting more like a lights out machine, like we were talking about earlier, we can now automatically look for one of these sister tools and say, okay, I'll grab that one and I'll continue running. Now that on the surface is a great way to start managing the life, but the other challenge that we always really had to lend to more skilled machinists and operators was, is the tool even cutting accurately? And this falls back to what we talked about real early on, which is that whole in-process probing concept. So there's two tasks when you start to look at in-process probing. You got the kind of orientation of the part and setting of the part zero to alleviate any inaccuracy in loading, whether it was from a human or from even a robot, right? This stuff never goes in the same place twice. But then you can do a strategy called measure, cut, measure. And what that does, it allows us to take a probe, a part probe, come down to a feature and say, hey, is this feature that was cut by, let's say, that end mill, is it to size? Oh, it's not to size. Okay, now since I know how much the deviation of the tool was, I can adjust the tool diameter, the tool length, whatever part of the geometry it's critical at that point. Let it update. The system then can be smart enough to say, okay, I know that the part's not in spec yet. Let me go grab that now adjusted tool, recut the feature, check the feature again, and continue that process until you bring it within spec. and then it moves along. So now the CNC is effectively QCing your part while you're manufacturing it live.
That is a game changer. So let's look ahead and, again, given your experience and the things that you see and the people you talk to every day, what do you think is kind of the next big thing in manufacturing? We talked about CNC, automation, robotics, and everybody's talking about digitalization. How do you think the major manufacturers in, aerospace, as you mentioned earlier, automotive, and even in job shops will be impacted by advanced manufacturing technologies?
So I think the world all wants to and expects me to say AI. AI is the future.
I hope you don't. I'm just kidding.
And I'm not going to. And I'm really not going to. Let's face it, AI has a place. And I think AI will impact our industry for sure in some areas. But if we want to look at things that I'm seeing trend-wise that are already starting to kind of directly impact how successful a manufacturer can be producing products, I would say it really comes down to mixed technology. Now, we've been doing forms of mixed technology for a lot of years, but a lot of times it was the kind of the outlier OEMs that were bringing these types of machines to market. They were very complicated. They were very expensive. But what I'm seeing now this technology is becoming more and more approachable. So where, you look back 10, 15 years ago, 5-axis was like, oh my God, nobody has 5-axis. You got to be the top of the heap, so to speak, to even afford a machine like that. Now you look at it and just about every OEM is producing a BC kinematic style 5-axis machine. And, what does that allow to a user? Well, it allows them to machine multiple sides of a part and handle the part less, right? And that's the key. The less I have to handle a part, the more proficient I can be in making it, the more accurate it can be, the less time I have to move it around my shop. All those steps, they take time, they incur error. Well, the same thing can then be said by mixing multiple technologies in the same machine. So now it's a milling machine, but I can do turning in it. So I can do lathe features as well as mill features. And then you see, it's a milling machine that can do turning. And it can do grinding too, right? Or maybe we are, maybe we're exploring a machine like a turn mill where, because of its nature of a main spindle, sub spindle, all these extra technologies, it makes automating the process much, much easier. So I tell you, if I am going to look into my my crystal ball here and say what's going to be that next big thing, especially in the job shops, because it's already hitting the aerospace guys, I would say B-axis turning centers. They're going to be as commonplace in 5 years as 5-axis milling machines are becoming today.
We're going to log that, and we're going to come back to you in a series of years and see if you were right.
Sounds good.
So let's talk a little bit. We've talked about, skills training and reskilling and upskilling current workforce, or trying to get, employees to come into shops. But, getting the next generation of manufacturing employees and leaders into the ecosystem is important. I know that it looks like you spend some time with your high school robotics team, the Bad News Gears, to compete at first robotics competition. So I love that. And, we talk a lot at SME and in our publications and on podcasts about, what the industry as a whole can do to engage and inspire the next generation of current students and young people to not only want to work in manufacturing, but can see themselves having sustaining careers in manufacturing. And I would love your perspective on what how you think that technology plays a role in helping to get people on board and position manufacturing as a sustaining career.
It's a great question. And honestly, I think a lot of it comes down to just making it exciting. Right? We had this stigma in our trade that it's a very, dirty, low level, dangerous type of trade. But then, you walk into shops, and I'm not even talking about aerospace shops. I'm talking about, average job shops, and you can eat off the floor, right? These are beautiful facilities. You're running, top of the line machines, right? So I think the trick is, how do we expose this next generation to what our trade actually looks like, what you're really doing, because a lot of people enjoy working with their hands, working with their minds, using computer systems, and not everybody's going to be a gamer. It's just there's not enough space. But if you think about it, I mean, a CNC is kind of like a giant video game. So for us, we like to certainly promote through our YouTube channels. As you mentioned earlier, the Mr. CNC channel is a great way for us to kind of try to incite the space. We also do quite a bit of a collaboration with Titans of CNC, and I think Titan has done a great job embracing that, right? Making the trade excitable to that next generation and even approachable. And I think we all have to do a lot more of that. There are some other influencers I think have done a great job. NYCNC was one of those that certainly used to put out a lot of great content, but I don't think there's enough of those guys. And we got to keep growing that ecosystem to show people that this is a very viable trade, and it's a trade that it requires kind of the best of our best, right? We need highly skilled people to be able to come into this trade, because these systems are not easy. This is not simple. We can try to make the controls as simple as we can to kind of offset the skills gap. But at the end of the day, you need somebody in that shop that is at a very high level. So we need it kind of excite that next generation. I think we can do it with social media and just showing the trade. I think the trade itself can stand for itself if given the opportunity.
Great. Well, you are certainly an ambassador for that topic. And if people want to learn more about the work that you and your team at Siemens are doing, and as well as the Virtual Technical Application Center, where should they go?
So I would say two places. One, as we mentioned, our Mr. CNC YouTube channel is a great stopping point to kind of check out what we have done. But we also have our CNC for You website. And CNC for You, it's the full address is usa.siemens.com/CNC for You. But I'll be honest, I never typed that out. Go to Google, type in CNC, the number 4, and the word U, Y-O-U. It pops right up, click on it. But that is our primary landing point for all things really end user focused. So operation and programming topics. And you can see all the training classes we offer, all of the other video material and content we produce, as well as linked to the entire Siemens ecosystem. We have a global footprint and presence, so you can see content that was done in Germany, it was done in Asia. So it's a great kind of landing site to educate yourself more on, what we're doing and how we're trying to drive the trade forward.
Wonderful. Well, Chris Pollack, I want to thank you so much for taking time to join us today. And I also want to thank our listeners for tuning in. Don't forget to like and subscribe to our podcast feed to stay up to date about what's happening in advanced manufacturing. And also, you'll find a host of resources by visiting us at advancedmanufacturing.org. Take care, everybody.